That's right, ladies and gentlemen. We are the Ask Academy. We are the Ask Academy, and here today we are here to talk about some pre-calculus, and specifically some things that we've been working on. So, moving me and those kind of concepts that we've been doing. So, I want to visit with you that day a little bit. Again, we are the Ask Academy. Today in our pre-calculus class, we were working on a concept of moving me. So what we did briefly is we took went on collected data, and we were able to collect some information in a table format. And so I'm going to make up some numbers that simulate that, where we were collecting time in seconds and connecting that to a distance, our location, or where we were in feet as we moved. So we started at 0, and that's the time we started at 0 and the distance that we were at 0. And then we moved for 15 seconds, and let's say that I moved 20 feet away from that starting point. And then I stood there for 30 seconds at 20 feet to record my movement and my position and where I was. And then again we moved for 15 more seconds, and let's say that I had gotten to, well, let's say I came back to there. And then again I stood there for 30 seconds and I recorded where I was. So that's a semblance of what we did tabularly, where we collected some information like that. And then I wanted you to go to a graph and put together what we are referring to as a piecewise function, where we're putting together a number of pieces of me moving and putting them together, connecting them so that they look like they are a function. And so we're going to use an XY, or a vertical or a horizontal coordinate system, where the horizontal is modeling our time in seconds, and that the vertical is modeling our distance, again, in a unit of feet. And so I'm not using graph paper here, but I'm just going to plot these points to give you a resemblance of what I want you to be able to do in this particular activity and project. So 15, 20, 25, 30, 35, 40, 45, and then 50, 55, 60, and then 65, 70, 75, 80, 85, 90. And in that time frame, 45, you were at 20 still, because you were sitting there waiting after recording, standing still. And then we went back down to 10. We moved back toward the starting place at 10 and 60 seconds, and then again we stood there and recorded that. So connecting those gives you a pictorial, a graph, a picture of me moving over that time frame of about a minute and a half, 90 seconds. And so by connecting those dots, it also gives you a picture of me moving me over that time frame. So those are the things I asked you to do to be able to get that. And other things I wanted you to do is to number these pieces. So here's one piece that you're putting together with a second piece, and together with another third piece, and then with a fourth piece, to make this piecewise function, because you were moving it different ways. Then that's what I wanted you to be able to depict, that data that we collected outside the academy that one day. The other things I wanted you to do with these pieces is off to the side, communicate each piece. And I want you to communicate the speed you were moving, the y-intercept of that particular piece, and then also to write the function. And so I'm going to do that with the number 1. Actually, I'm going to do it with the more difficult one, the third piece. Use that as an example. So here I've got two coordinates. This third piece comes from this 45 and this 60. Those are the two coordinates. Your 45-20 and your 60-10. Those are the two-dimensional coordinates. And so what we're going to do is find the speed. Well, we found that speed is the rate of change. the slope of the line. So that slope is how, if we determine the slope, then we've got the speed. And at this particular direction, it's going down or in a negative slope. So that particular slope is going to be negative. Now your speed is really a positive thing, unless you're referring to it as a velocity, which will also communicate a direction of that particular speed. But here we're just talking about speed, and so in the formula, we'd actually take the velocity, determining that direction as well. So if it's negative, it's negative, it's positive, it's positive. And the way we learn to do that is it's rise divided by run. So the rise is determined by the y's, and so I'm going to go 20 minus 10. Well, if I subtract in that direction, then I've got to subtract in the same direction, and doing that I get negative 15. 45 minus 60. And so that's going to get me a positive 10 divided by a negative 15, which can be simplified and reduced as a fraction as negative 2/3. But we're talking about speed here. Yes, we know it's a slope, and that's how we're going to plug it into the function, but the speed is 2/3 of a foot per second. 2/3 feet per second. And it's negative, communicating the velocity or the direction of that particular speed. So the y-intercept then is found in a more difficult way. Now again, we've learned a method of finding that. I'm just going to use this particular thought. If we extended this line on out so that it crossed that y-axis, I could estimate by pictorial, by graphic method, to determine what that, or estimate what that particular y-intercept is. 20, 25, 30, 35, 40, and so it's again, it's an estimate because we're not using graph paper. It's not very accurate at all, but that y-intercept should be close to 40-ish. How do we find out what it is precisely? We use algebra, and what you were taught was you write the equation down in y-intercept form, slope-intercept form, where m is the slope and b is the y-intercept, and then I taught you to put values in for x and y so that you could solve for b. Well, let's do that. Let's do that like we did in the book, but we're going to apply it to me moving, to this activity of moving me that we collected data on. Again, so I'm going to use this line. I'm going to use the 2 points, or I'm going to use the value for slope that we just figured out. So your slope, your m, is negative 2/3. But then I can use either of these two coordinates that have these two values, this point or this point. X is 45. I'm going to plug in that one, choose this point. Y is 20. Since its y is 20, or the distance, the vertical component is 20, y, I'm going to plug that value in for that y in the vertical component of the formula of the equation. And then I've just got b. I don't know what b is. B is representing the y-intercept. So algebraically, I can determine this incredibly accurately. And so let's do that. Now I have to just do the arithmetic, isolate, and leave b on the right side of the equation. It's going to tell me the numerical value for that. So 2/3 of 45. 45 divided by 3 is 15. 15 times 2 is 30, but that's negative 30. Plus b equals 20, and moving that negative over I get 50, and I said it was going to be close to 40, 45-ish by eyeballing it. Well, we got really accurate to learn that it was 50. So this y-intercept for this particular equation is going to be y is equal to the slope times x plus that y-intercept. So that's algebraically, we're going to apply what we've learned. How fast were you moving? Were you moving about 2/3 of a foot every second? Fast or slow? Pretty slow, actually. You weren't moving very fast. But because it's negative, that tells you that you're moving back to the line. And this told you where you would have started had you been back here at time 0 at the y-intercept. So that's the y-intercept, how you find it, the function, how to write it, and determining the speed in that piece. You're going to do that for every piece. Now this is flat. Your slope of a horizontal line is 0. And so this equation's going to be different. But the process by which you can go to